Let's answer the following true and false questions. So we have f and g are antiderivatives, or half antiderivatives of capital F and G. So does this imply that capital F and G is an antiderivative of this function? Well, let's see. Lowercase f is the antiderivative of f. That's what this means. And then this, the integral of g, capital G is lowercase g. So does that mean that capital F and G is the integral of capital F times lowercase g plus lowercase f times capital G? So this is what we want to see. Well, this is just f times capital G prime plus capital F prime times G, which is really capital F times G prime. And when I take the antiderivative of this, I do end up with capital F times G. So this is indeed true. So think of that as the reverse product rule. Now if f is an odd function, then integral from negative a to a of f of x dx is equal to 0. Well, if it's odd, that means that f of negative x is equal to negative f of x. So I can split this up into two separate integrals. Now if I let x equal, let's say, negative u, dx will be negative du. And so when x is 0, u is 0. When x is negative a, u is a. So this is the same thing as just doing negative and then flipping the limits. So these two things are identical, except one is a minus, one's a plus. So they're going to cancel each other out, and you do get 0. So this is indeed true. Now what if f is an even function? Does that imply that it's the same thing as twice the area from 0 to a of f of x dx? Well, if it's even, that means f of negative x is equal to f of x. Now, I should have said this is equal to negative a to a of f of x dx. Okay. So let's take negative a to a. We'll split it up at 0. So we'll have two separate integrals. If we let u equal negative x, du will be negative dx. So if x is 0, u is 0. If x is negative a, u is a. And then this will be negative u du. Now because f is even, f of negative u will just be f of u. And then I'm going to flip the limits. And when I flip the limits, I'm going to put a negative in front. And I did forget also, when I take the derivative, to put a negative outside, because dx will be negative du. So I flip the limits and I get another negative outside. So really this is just positive integral from 0 to a f of u du plus integral 0 to a f of x dx. These are exact same integrals, so therefore we can say it's twice the integral from 0 to a of f of x dx. So again, this is also true.